Hello everyone. Today I'm going to explain topic about Hadoop framework architecture. Myself Raviteja Padimari and my teammates are Bharat Narendruni and Sai Krishna Marishetty. Today the topics I'm going to cover is what is Hadoop, how Hadoop works, and Hadoop framework architecture. The topics I'm going to I will give a brief introduction about Hadoop and when data gets into the Hadoop, how it will be processed the data and the framework architecture of Hadoop. Going to Hadoop. Hadoop is a software framework for distributed processing of large data sets across large clusters of data. Large data sets are nothing but the huge data. Let's give you an example. Let's get a database for an educational institution or a business company. It's a group of if a group of educational institutions or companies have group of database of these things combined to a data warehouse. It's a huge amount of data. When the combination of data warehouses is called the big data. To process these type of huge data, Hadoop is used. Hadoop is one of the most efficient tool to process the data from a huge clusters of data. Okay. And Hadoop is an open source implementation for Google. Google implemented the Hadoop first by the name MapReduce, and later Yahoo developed it. Hadoop is based on simple data model called any data will fit. Any data can fit means it has different types of data, different formats like videos, photos, different formats. The main thing the Hadoop is going to process is is on MapReduce. It's divide the data by using some techniques and reduce the data to fix the necessity. Okay, and coming to traditional databases, it has a small amount of data and it can process only certain limit. And when coming to the big data, it's a combination of databases, and so it cannot handle the big data. The traditional databases tools cannot handle the big data because it's a less computational power, the speed is low. So the Hadoop is mainly used for that. So it is a main disadvantage of the traditional data management tools. It can overcome by using the Apache Hadoop framework. It can store the data, it can manipulate the data, it can extract the information by using from big data. And the next topic I'm going to cover is how Hadoop works. Let's say if a data gets into the Hadoop and how it is processed and how it is divided and how it will be get into the output. Okay, the main Hadoop architecture is divided into two parts. It's a Hadoop distributed file system and MapReduce. The main topic, if a data gets into the Hadoop, let's say it is a name node. Name node is nothing but it is a centerpiece of the HDFC file system. It keeps the directory tree of all files in the file system and tracks where across the cluster of data is kept, and does not share it does not have the data of these its files itself. It will process the data, and the name node is the main data which we're going to give to the Hadoop, and it is divided into several nodes called data nodes. The data nodes are nothing but it just stores the data in the Hadoop file system. A functional file system has more than one data node. The main data is a huge data, so Hadoop will divide the data into different data nodes. These are known as slave nodes. The division is depend upon the size of data, the type of data, all the factors. The Hadoop HDFC, Hadoop Distribution File System. Hadoop Distribution File System is designed to store very large data sets reliable to stream those datasets at high bandwidth to user applications. Hadoop provides a distributed file system and framework for the analysis and transformation of very large datasets using the MapReduce paradigm. The main properties of HDFC FSO, it has a very large data. HDFC instance may consist of thousands of server machines, each storing part of the file system's data. The replication. The main advantage of the Hadoop or the process it is going is the replication or the data reliability. See, if we store a data in one system, let's say the system has been crashed, so all the data will be gone forever. So what the Hadoop does is, if there is a data, it makes the copy of the data and places the copies in different machines, so that if one system has been crashed, the data is copied to other machines, so it has the data from other machines also. It's the main advantage. Each data block is replicated many times. The default number is 3, so the Hadoop takes a copy of 3 times. Okay. Failure. Hadoop has no failure till now. Failure is the norm rather than exception. Fault tolerance. Detection of faults is quick automatic recovery from the core architectural goal of HDFC. Name node is constantly checking data nodes. As the main data is divided into data nodes and name nodes, always the data nodes should be communicate with the name node to get the data, to process the data, the calculation time, and all those things. And coming to the MapReduce engine. MapReduce engine is the main part of the Hadoop file system. Hadoop MapReduce is a software framework for easily writing applications which process vast amount of data in parallel on large data sets. MapReduce job usually splits the input data sets into independent chunks which are processed by the map tasks in a completely parallel manner. The framework sorts the outputs of the map, which are the input to reduce tasks. Typically, both input and output of the job are stored in a file system. The main use of the MapReduce engine is the data that we give to the Hadoop is large, as I told. It will be divided into certain amount of parts based upon the type of data, size of data. It is done by the MapReduce engine. The MapReduce engine has two parts, master node and slave node. Master node is also called as job tracker, and the slave node is called as task tracker. The job tracker. The first point, the Hadoop gets the data. It will goes to the job tracker into the MapReduce engine. It will goes to the job tracker. It receives the user data, and it is the master node is the main part which divides the data into different parts. It is and the job tracker is also known as name node, the name node, which divides the data into several data nodes. Okay, this is called the number of maps. Okay, and these mappers, the data will decide and will be gone into the data nodes, and it will decide where each mapper should go. It's also nothing but concept of loyalty. And coming to the task tracker, the name server, the task with the job tracker divides the job into several partitions, and the task It receives the task tracker will receive the job from the job tracker, and it will runs. It is the main part. So because it is running the part, it is running the task. It runs the task until completion of the data. And the main important thing is it will be always be communicating with the job tracker, reporting the progress. If there is any faults in the system, it will directly give to the job tracker. So job tracker will communicate with the user. So when the data is sent to Hadoop to process, it will use its architecture to divide the data on to process the data. The process contains of a lot of things, and I will give a brief explanation how the data is going to processed in the Hadoop. The main Hadoop uses the Google's MapReduce using Hadoop distributed file system. The MapReduce, as I explained before, it will divides the data into small blocks, so it will be easy for everyone to work on the small deadlines. And when the MapReduce divides the data into small blocks, HDFC, now comes the part of HDFC, creates multiple replicas of data blocks for reliability. For the reliability is one of the property of HDFC. It will take the copy of the data and stores in different machines. If there is any crash, it will be used, and HDFC will place the data blocks on a computer nodes around the cluster. So it will divide the data, and it will send the data to process to the data nodes. And then MapReduce. Now the MapReduce, the name node, data node, the data node will be process the data, and will return the results to the user. The same way, if there is any error also, it will return to the user as well. Hadoop target is to run on clusters of the order of 10,000 nodes. Let's say Hadoop is usually developed to handle the huge data. So it is it is a diagram showing to how the data is going to divide and how do we get the data. Let's say the data or the huge data and the user gives will be going to the cluster. The HDFC divides the data into different blocks. Here the data is divided into 3 blocks, and this is done by HDFC. And and then here comes the part of the Hadoop MapReduce. It will scan the data and reduce all the matter into specific amount, which could be easily stored and easily processed. And the process will go in. After all the process, the result, we will get the result which is useful to the user. Now going to the Hadoop framework architecture. It's a main important topic of the presentation. The Hadoop framework architecture is mainly divided into 4 major categories: the MapReduce, storage, ecosystem, and miscellaneous other. This is the diagram. It has the Hadoop architecture is divided into 4. The mainly MapReduce contain how it depends upon all the data scheduling, how the data process, how the data flow, and how the data is stored. And data storage manipulation is will be having all the details of databases, queries, all the ecosystem. And the miscellaneous depends upon energy management, data security, all these kinds. Going to the MapReduce. As I told, the first point of the MapReduce is scheduling. Scheduling is a method by which threads process or data frames or given access to the system resources, the scheduling will be done by schedulers. The main point the schedulers are concerned about the throughput. Throughput is nothing but the number of process to the total number of process their execution per unit time. Hadoop comes with three main schedulers: the FIFO, FAIR, and capacity. The default Hadoop scheduler is the FIFO. FIFO is nothing but first in, first out. Let's say if there are first in, first out, the name suggests the first one who gets into the ready queue, it will get its job done. Where jobs are loaded into the queue and scheduled to execute according to their order in the queue. And coming to the next scheduler, FAIR scheduler. The name suggests that it gives a good number of clusters capacity over time. That's it. Depending upon the cluster capacity, it gives a process to the ready queue and process the data. And third scheduler, nothing but the least capacity scheduler, was developed by the Yahoo to guarantee a fair allocation of computational resources to a large number of cluster users. It is also one of the schedulers used. And coming to the second part of the map reduce, it's a data flow. Data flow is nothing but how the data will be processed in Hadoop, how the data will be flown. It has mainly two parts: map and reduce. And as there are two parts, and they are called two workers working on over there: the mappers to map the task, and the reducers to reduce the task. The mappers are used to let's give an example. They will scan the data, and they're gonna give the data to the reducers, which will delete the unwanted data, and all the data will be combined again and gives a reduced data. The map reduce job is divided into map and reduce job and assigned to idle slots of workers according to these two stages. In the first thing what happens in this Hadoop is, first the input is loaded into the HDFC. The input from the user is loaded into the HDFC, and to ensure fault tolerance, as I was already told, it's a data reliability. The HDFC will divide the data. HDFC will make the copies of data and stores in different machines. And before making a copies of data, the HDFC will divide the data into equal sized blocks. After that, it will make the copy, and it will send the data to the map reduce engine to do its map reduce tasks. And after HDFC division of data, it will be then sent to the mapper. The mapper scans the data and reads the data, and it will provide the intermediate outputs. It will provide its output, and they are locally sorted, and then it goes to the reducers, which will reduce the data, and after all this process, the data will be stored on the local disk of the mappers. Coming to the second division of the Hadoop framework architecture, it has 7 parts. All is depends upon the database storage. Okay, and the first part in data storage and manipulation is storage and replication. And the Hadoop distributed file system is the block storage layer that uses to keep its files. HDFC were designed to hold very large data sets reliable using data replication. Its architecture is composed of two main entities, name node and data node, which work in master-slave fashion. Earlier told, name node will get the user data and it's going to divide the data into different parts. Data node will be process the data. Name node is responsible for keeping the metadata about what and where the files are stored in the file system. Data nodes are responsible for storing the data itself. Cloud computing. It comes a good topic. Cloud computing is typically defined as a type of computing that relies on sharing computer resources rather than having local servers or personal devices to handle applications. The cloud computing, the cloud is nothing but the internet. Cloud is nothing but the internet. Computing means the type of internet-based computing. Nowadays, cloud computing is a very good topic, and Hadoop was not originally conceived, not originally designed to work with the cloud. There were many Hadoop technologies came to work with the cloud, but the one of the important is ODFC, Optimus Data Manager and Distributed File System. It uses the main HDFC as a base to work the Hadoop in cloud. And the main important of cloud computing is paper use as how much you pay, information as a service, platform as a service, backup. All these are the main advantages of computing. Okay, and as the Hadoop is not originally designed with the cloud, it has after ODFC, the system after ODFC, the Hadoop came to know it should have its own methods to deal with those kinds of computing technology. So the file system adds a RESTful good number of interfaces to expose critical functionalities from Hadoop as a service and extend HDFC. These components are used to enrich security, logging, and data analysis features. In the cloud computing, the main thing we need to focus is the security, because as the cloud computing is done all in the internet, everyone can access it. So the security is the main important. To avoid security, one of the thing is logging is good way to prevent loss of data. Components also provide data access compatibility between federated clouds. Now coming to the other part of the storage and data storage and manipulation, it has deals with the database management system, indexing, querying, and random access. Database management systems. It's nothing but storing the data and processing the data. Indexing. This how we store the data. Querying. After storing, we have to get the data. By using the queries, we're going to get the data. Random access. Okay. Although HDFC shows good performance and scalability, fault tolerance, high throughput, and all those things, it prevents in some context. It prevents some drawbacks in some context when compared with database management systems. We got many proposals how to improve its performance when compared with database management system, but Professor Leo proposal is the best according to the knowledge I have. He proposed the use of built-in hierarchical indexing to support complex type queries in HDFC. This type of methods also used in hierarchical structures which are applied in B tree or tree. B tree is nothing but it's a tree data structure that keeps data stored and allows such as sequential access, insertions, deletions, updates in logarithmic time. B3 generally uses the binary search tree to process data. Indeed, Hadoop concentrates on query processing, particularly query execution plan. The proposed system boosts task performance without changing the Hadoop. Its main advantage, Hadoop DBMS hybrid system will completely replaces HDFC by a parallel DBMS. The basic idea behind Hadoop DB is to use MapReduce as a communication layer above multiple nodes running single node database management system instances. Coming to the third part of the framework architecture, it uses the high. One of the thing explained in ecosystem is high peak and H base. The map reduce paradigm is not suitable for all problems involving the large data sets. Okay, and see everything is not perfect. The four modules that currently compose the Apache hardware are Hadoop Common, HDFC, MapReduce, and Yarn are well suitable for unstructured data. However, in processing the old-fashioned structured data, Hadoop may suffer from performance issues. The performance is the main thing everyone looks at into it. Since the framework was not originally developed to process this data, the performance will be reduced a little bit. To overcome these problems, several Apache Hadoop related projects have been developed over the past few years. For example, these are the it is one of the high level data flow language and execution framework for parallel computation. Mahout, a scalable machine learning and data mining library. Have a data warehouse infrastructure that provides data simulation and querying. HBase is a distributed database inspired on Google Big Table. These are all projects came out the past few years to increase the performance of Hadoop. Miscellaneous. The other categories we're gonna discuss on Hadoop framework architecture is energy management, GPU, and security. Energy management. Nowadays, energy is the main concern about all the factories, all things, because because of the cost. The reduction of the cost is the one. The reduction of the cost of the hardware and energy consumption should be decreased by using to decrease, and we should not decrease the performance. So the authors all developed the green Hadoop, which was proposed by Goiri in 2012. It's Apache Hadoop variety of data centers powered by photovoltaic solar and arrays and electric grids. It's a green energy and brown energy as a backup. They tested many processing of data, and the objective is to investigate how to manage the computational workload to match the green energy supply in small or medium centers running data processing frameworks. GPU, incoming is the next topic, and general purpose computing on graphic processing units is a technique to use the commodity GPUs to perform general purpose computation in application traditionally. Coming to data security and cryptography, data security is the main thing we should concern about the cloud computing technology. Apache Hadoop data is stored according to the user accounts. Some studies address these problems, presenting solutions to enhance both Hadoop data security and confidentiality. In open systems, MapReduce faces a data processing service integrity problem. Since service providers may come from different administrative domains, they are not always trustworthy. This is to achieve those things, it is achieved by using decentralized replication-based integrity verification scheme for running MapReduce in open systems. Thank you. Thank you, everyone.